Alright, so let's start talking about 1.1. This is our measuring segments and angles. Most of this slide is already in your notes from the vocabulary, but what we're talking about today are segments, which are two defined endpoints. So it's a line created by 2 points. That's really what we're going to focus on today. A ray is one endpoint and all of the points on the line on one side of that endpoint. So a ray will have a definite beginning but no defined endpoint. And then a line is infinite in every direction. All the points that are collinear lie on the line, and there's an infinite number of collinear points. And an angle is formed by two rays with the same endpoint. So here's our endpoint here, and our first ray, because it doesn't have a defined endpoint here, so we're going to call this a ray. We can call this a segment if you want to consider this to be an endpoint. Typically these continue on forever. So here's our first ray, here's our second ray, and the space in between them is the angle that is created. Alright, so we're going to start with our first postulate. This is the ruler postulate, and it says every point on a line can be paired with a unique real number. This number is called the coordinate of the point. We've done this before. We've done this usually. So this is a real number line. And when we've typically done it, we've done it in a real number line by a real number line. Then let's look at that. So what we're dealing with now is a real number line. And what you would normally use in your other classes, especially in Algebra 1, is this. This is a real number line. This is also a real number line. And this plane is called r squared. What we're working on today was just the one. This line alone is just called r. It's a really bad r, but we'll get better as we get used to this new tablet. Okay, so let's go back to what we were working on. So here I have the coordinate of a is 0, and if you look, a aligns with 0 and b aligns with 3. Kind of the same thing we've done before, but now we're actually going to start talking about length, distance, segment distance. So we're starting from the bottom and we're going to move up to more difficult ideas. Alright, so the length of a segment is always a positive real number, and it always has a corresponding point on the real number line. Length can never be negative, and we'll look at that later, and I'll show you using two segments. We'll look at them from left to right and right to left and see that they're always come out positive by the ruler postulate from the previous slide. So if I have these 2 points, A and B again, to find the length of the segment, we have to find the distance between them. And anytime we say distance between, that's going to be subtraction. So what I always do is take the number on the right, which is B, and its value is 3, and I subtract the numbers, the point on the left, that value is 0. So what I ended up with is 3 minus 0. So to find the length of segment AB, we subtract 0 from 3, which looks like 3 minus 0 is equal to 3. This symbol means therefore. We're going to use that a lot in this class, so I'm going to introduce it now. Therefore, the length of segment, this bar across the top means segment AB, so that's from here to here, is 3. This can also be written as the length. The absolute value bars, because the length can never be negative, are used, and this means the length of segment AB. So the length of segment AB is 3. We're going to start going from full written out English sentences to these symbols. It's going to be more efficient, and you're going to need it for proofs coming up later in the month. So let's look at how to do some of these on example. I'm going to switch them over to the screen. Okay, so to find the lengths of the following segments, we're going to look at this wants to know the length of segment AB. So I'm going to find A and I'm going to find B. B is on the right, so I'm going to start with B. All right, so B's corresponding point on the line is 4. So I'm going to start here with 4. Let's try it. All right, so the value of B according to this is 4. And I'm going to subtract because it's the difference of the 2 points, 4, and then A's value is, well, negative 4. So I'm going to have 4 minus negative 4, which is the same as 4. And then if I distribute the negative in, I get 4 plus 4. And that is equal to 8. Now if I want to check that, I can go up to the number line and I can count how many steps it takes. 1, 2, 3, 4, 5, 6, 7, 8. That's fine to check your work. You can do that on the quiz, you can do that on the test. But I want to see that I want you to show me that it is the distance between the 2 points. Because when we go to r squared, which is our normal xy coordinate that we've used in Algebra 1 and before, we're going to have we're going to have an additional variable to work with, so I want to start getting this process down now. So check your work by counting and skipping along, but make sure that you actually know how to do this when you're showing us work. The next slide, or your first participation slide, is going to be this all over again, and we're going to have to show it. So we know this is 8. So let's look at AC. C is 1, and A is still negative 4. So C is on the right, so I'm going to start with that. I'm going to do 1 minus negative 4. Distribute these in again. So then I'm going to end up with 1 plus 4 is equal to 5. And I could check that up here again. 1, 2, 3, 4, 5. So then AD. D is on the right, and it's negative 2. A again is negative 4, so minus negative 4. Double negative means negative 2 plus 4, which gives me a length of 2. So I can come up here and see that, yes, 1, 2. So it feels repetitive now, and it is, but this is a good foundation for doing it with the additional dimension in the XY coordinate system. So BA, now I have 4 for B. B is on the right, so I'm going to start with B, and then I'm going to do minus negative 4. As you notice, I wrote the minus sign before I even saw A's coordinate, because I know I have to always do that. 4 minus negative 4 is 8. Now this is what I wanted to show you. Here we have AB and BA, and they're both 8. And if you think about it, segment AB goes from left to right, 8 units, and BA starts at B and goes to A, and it's also 8 units. So we're going opposite directions. From B to A is what we can traditionally consider the negative direction to the left, but we're still ending up with a positive length. So length again can never be negative, and that's why we use the absolute value bars to signify length. DC is 1 minus negative 2, which is 3. Right, so the value of C, let's do it in a new color. So I have C and D. C is on the right, so I'm going to do 1 minus negative 2, and that's going to give me 3. And we can see 1, 2, 3. All right, so that's that. So here it is for you to try. Now, this is how I know you're watching the videos, and this is how I know you're going through everything. Go ahead and solve these. Pause the video, of course, and then when you finish, just bring them in, drop them in the turn-in bins, and we'll move on from there. But again, remember, so for AB, I'm going to start at B, which is 0, and I'm going to subtract -5 to get my length. Remember to take the absolute value if you end up with a negative number, and you'll be fine. All right. So the postulate 1, 2 is the segment addition postulate, and it just says if points A, B, and C are on the same line with B between A and C, then A plus AB, segment AB plus segment BC is equal to segment AC. Let's look at that real quick on the other screen. So here's my number line. Here is A, here is B, and here is C. And what that's basically saying is if I have the length AC, and let's draw a line segment between A and C. Then if I have the line segment A and C and I interrupt it with point B, which is what I have right here, then from my A to B, so let's do A, B. I apologize for this handwriting. So from A to B is now here, and then if I take from B to C, and let's do a different color. So if I take AB and add BC to it, then I should get the full length of AC. So let's look at it again. What was this color? There we go. Okay. So from here to here is AB. Now I'm going to start BC. Remember, these are all collinear, so they land on the same line. And then if I were to be able to draw a straight line up, that is not a straight line, but basically taking AB, adding BC, I end up in total with AC. So that's all it's saying. And if you can think about it as if you have a sheet of paper, if the left edge is A and the right edge is C, and you tear it straight down from top to bottom, at any point, you've now created point B. If you take those two sheets of paper, you have section AB and section BC now, but if you put them back together, they'll be the exact same length as the original paper, which was length AC. So let's look at the PowerPoint again. So if I have A, B, C, there it is, A, B, and C. If I go from A to C originally, that would be 1, 2, 3, 4, 5, 6. And then if I go from, I create this point B, now I have from A to B, which is 1, 2, 3. And from B to C is also 3, 1, 2, 3. AB's 3 plus BC's 3 is equal to 6, and AC is equal to 6. That's the segment addition postulate. That's also doing it arithmetically. Now we're going to look at doing it algebraically. So if I give you this segment, the segment FH, where G is in the middle, so F is our A from the previous slide, H is our C, and G is our B. G is interrupting FH, and now you see that they have two algebraic expressions. 3x minus 1 is equal to the length of FG, and 2x plus 2 is equal to the length of GH. They're collinear, which means they fall on the same line, so that if that means G interrupts that line, we can now find what they're equal to if we know one of the values numerically of FG or GH. So our next slide says we know what collinear means. If GH is equal to 16, so let's move that over to the other side. I'm just going to take this piece. Uh-oh. There it is. Alright, so now we're looking at GH is 16 by definition on the other slide. So let's fill that in. So this is 16. So we know to go from G to H, we have to move 16 units. We also know to go from G to H, we have to go 2x plus 2 units. So what we can say is 2x plus 2 is equal to 16. And that's just given information, right? We know GH is 16 units. We also know G to H is 2x plus 2 units. So now if we solve for x, we'll know, excuse me. Now we're going to solve for x, and that's going to allow us to find out what the number value of FG is. And then if we have the number value of FG, we can add it to GH to get FH overall. So let's do that. So I'm going to subtract 2 from both sides. It's going to give me 2x is equal to 14 divided by 2. X is equal to 7. So now that I know x is equal to 7, this is not what FG is. This is the value of x. And if I want to show you that, I guess, a little bit more clearly, what I can do to test to make sure I did it right, so I can go back into what I started with. And if this equals 16, then we've done it correctly. So I have 2 times 7 plus 2. That's going to give me 14 plus 2, which is equal to 16. So since this and this are the same number, we verified that x does in fact equal 7. So what I can do here is take 3 times 7 minus 1, because I've taken my x equals 7 value and plugged it in here. And I'm going to have 21 minus 1, which is 20. So my FG value is 20. Let me scroll up here real quick. So we know FG is equal to 20, and GH is equal to 16. So then if I do the length of FG plus the length of GH, I will find the length of FH. And since that's what we're looking for on the other slide, what is FH? I can now say FG is 20. I can say GH is 16. And I can say that FH is 36. So the entire length, F to H, is 36. This is doing algebraically. It looks more complicated, but as long as you're given your 3 collinear points, their expressions algebraically, so FG's expression is 3x minus 1 and GH's expression is 2x plus 2, and you're given a defined value or number for one of the 2 segments. In this case we have GH, the one on the right, is 16. We can then find f of h. Now, while we're on this, we know that this is 20 and this is 16. If you look at that, you say that's crazy that this could be 16 units and somehow this is 20 units. And the reason I chose this example, I made them so obviously incorrect looking at them. This is the same as saying this is 20 inches while this is 16 inches. Visually, that makes no sense. But what we're doing in geometry is we're moving from looking at something and saying, yes, this is verifiable by our sight. We can't trust our sight anymore. Everything has to be done through proof. If you make a statement, you have to back it up with proof. We'll learn postulates, axioms, everything in this class to prove or back up what we're saying. So keep in mind, if visually, 20 is definitely larger than 16, but the space of GH that it occupies on the number line is much larger than FG. Keep in mind, no matter what, we have to do everything by proof, never inspection in this class. That's why we chose this example. All right, let's move on to the next one. So now we're going to look at real quick. FG, this is the same problem. This is typed out. I went ahead and typed it out because I'm still getting my handwriting under control on this tablet. I had to buy a new one and I'm just not used to it yet. So we have the length of GH is defined as 16. Algebraically, the length of GH is 2x plus 2. So this just means here we know the unit measure. So let's call this inches. This is 16 inches from G to H, where 2x plus 2 represents the number of inches for any x value that you have. So if I know that GH is equal to 16, which is also equal to 2x plus 2, as you can see here, I can start solving for x on this side of the equation. So we've already done this. We're going to subtract 2 from both sides. That's going to leave us with 14. Divide by 2, we're going to get x equals 7. So now that I know what my x value is, I can plug it in here to check. 2 times 7 is 14, plus 2 is 16. These numbers check. This equation is balanced. So I know I can use my x equals 7 here to find the length of FG. That is 3 times 7, which is 21 minus 1. So FG is 20. So now I have the value 20 plus 16 will give me the overall segment length of 36. Okay, so here's your U-try. Go ahead and pause the video. In class, if there's a P up here, this is going on a separate sheet that you're turning in to show me your work. I'm not checking. You'll still receive full credit if your answer is wrong, but I want you working together. Whatever I ask you to do in class, if I ask you to work alone, I just want to see that you're following along and where my explanations may be falling short so that I can go back and cover them in the next day's bell work. All right, the protractor postulate. This is just basically saying, given the ray BA and a point C not on the ray BA. So here's the ray BA, and here is C. This point is not on BA, it's not collinear. A and B are collinear. They will map to a unique real number on this number line. This is a curved number line, but it's a number line nonetheless. As you can see, it goes from 0 to 180 in one direction and 180 to 0 in the other direction. We'll talk about why that is in just a second. What we are looking at is this angle. So we want to know, is the angle ABC acute, obtuse, or a right angle? So a right angle is 90 degrees. An obtuse angle is any angle over 90 degrees or greater than 90 degrees. And an acute angle is any angle less than 90 degrees. So ABC is definitely less than 90 degrees. So we're going to start on the side that is the 0. We're not going to start on 180. We'll do that with obtuse angles. But here we're going to start at 0 and we're going to move up. So it looks like ABC is 60 degrees. Now if I looked at angle DBC, this angle created by DBC is definitely obtuse. So I'm going to start here. On this side I'm going to do the 0. I'm going to roll all the way up to 120. Now these are called coterminal angles, meaning they end at the same point. So ABC is 60, DBC is 120. If they add up to 180, then we've read the protractor correctly. So ABC is 60 plus DBC of 120 is 180. All right, so let's look at a little bit more of a complicated one. Actually, that's not, we skipped. Okay, so here's our slightly more complicated one. Actually, let's talk about congruency first. So this is one of the most important things in this class right now. This is coming up in topic 3 and 4 and a couple more later on, but we have to understand congruency. And this goes right back to nothing in this class can be done by inspection. Everything has to be proven. And your congruency marks are one of the best things to show proof. And all they are is simply saying if you have two segments, AB and segment CD, putting this single mark here on both of them means they are the same length. They look exactly the same length, but unless they are marked for congruency, or we say that the length of AB is 20 and the length of CD is 20, we don't actually know that they're congruent. And one of the questions you may have on a test are AB and CD congruent? And not have any tick marks on there, like this one, or these two. And what would happen is if you said yes, we would say, how do you know? There's no information being offered that lets you know that AB and CD are congruent if there's no tick mark or no defined length in units. So you would say no in that case, but in this case you can say AB and CD are definitely congruent because they're defined to be congruent. Same with PQ and RS because they have two tick marks. Now PQ is not congruent to CD. We have two tick marks here, 1 tick mark here. The number of tick marks have to correspond with each segment for them to be congruent. All right, let's look at angles. Have the same rule. They just have little arcs in between their endpoints of their rays. So UT and UV create the angle VUT or TUV. Always read these with the angle in the middle, but you can start at either V or T, but make sure you use in the middle. So VUT is congruent to XYZ. Same as FGH is congruent to JKL. The same number of arc marks shows congruent angles. The same number of tick marks show congruent segments. So TUV is not congruent to JKL. So let's look at this problem, because this one's a little bit unique. It says if XWZ, let me bring it over too, just so we can really talk about it. So what this is saying is if the measure of XWZ is 127 degrees, what that's doing is saying, let's bring up a different color. XWZ, remember W being the vertex, XWZ, this entire green angle is 127 degrees. What it wants to know is what is the measure of angle YWV. So that's going to be YWV. So let's look at first, what do we know? XWZ is equal to 127 degrees, and that's the entire angle. And we're looking for this piece in the middle. And we also have the angles X, W, Y, and V, W, Z. So we don't want this. We don't want this. We do want this. So we take our total angle, XWZ, and we look for all the information given to us to see if we can figure out how to remove the value of this angle and the value of this angle. Oh, that's not a good eraser at all. All right. So the way this works is we have the overall angle of 127 degrees, and we know right now we don't want this 32 degrees, so we can pull it right out. Now we have a congruency mark here. We have a congruency mark here. So this tells us right now that this angle is the same. They're congruent. It's also 32 degrees. So I can subtract 32 degrees. Now I'm going to do this, and you don't have to do it this way. You can punch this into your calculator right here. But what I would normally do is 127 minus 64, and then that would leave me with 63 degrees. So I can now say that the measure of angle, this means measure of angle, YWV, W being in the middle, Y is here, so YWV is 63 degrees. So what we did was remove this angle. We removed this angle. We knew that together they were 64 degrees, and the overall angle was 127. So we did 127 minus 64 is equal to 63. All right, so that's our angles segment and addition and our introduction to all of that. We're now going to move on to midpoint and distance formulas. So we have, well, you don't have a shoulder partner because this isn't a video, but in class, this is something we'll normally do. And that is, you'll have a chance to kind of talk over everything with your shoulder partner so that you can start assessing your understanding, to kind of start you on thinking, what questions do I need to ask, or am I really good at this? Was I able to explain it to the person next to me in detail where I feel like they should be able to do it now? So if you've done that, you're ready. You can, take your notes and just let's move on. If you're struggling, start forming your questions now. So Define midpoint in your own words. This can be in regards to middle distance between two real points or 2 points on a coordinate system. So all that's saying there is you can think of it as on a number line or just in R space, which is the real number line, or an R squared space, which is the coordinate plane X and Y that you're used to from Algebra 1. So the midpoint is anything. If you take a piece of string, the point exactly in the middle of that piece of string, no matter what its angle is, where it's headed, where it's going, does it cross through the point 0, 0? Does it cross through, it doesn't matter what point it crosses through. The midpoint of a line is always at the center of the line. So here's the formula for midpoint. A midpoint of a segment is the point that divides the segment into two congruent sides. See, I said midpoint is just the center of a line, but to be more precise, you would say into two congruent segments, because two congruent segments that are collinear have to divide the piece equally. All right, so if we have the segment PQ with point P being at coordinate x1, just means the first x coordinate and the first y coordinate, and Q is your second x coordinate with your second y coordinate, we can find the midpoint by averaging the two x coordinates, which is exactly what we're doing. Our first x coordinate plus our second x coordinate divided by 2, we give you the average of the two, which the average means the middle. And then our first y coordinate plus our second y coordinate divided by 2 gives us the middle of our y coordinate. And then together, that new point, this is a comma. I had that in class a lot on Monday. This is a new point. So once you get this, you'll have a new point. So let's do one real quick together. So our A value is -3, 2. So I went ahead and recorded that over here. This is A, this is B. B is 4, -2. Now I want to find the midpoint of these, so I luckily had these line up, so I'm going to add them together by their coordinates. So here's my x1, here's my x2, here's my y1, here's my y2. So I'm going to have x1 plus x2, comma, y1 plus y2. I'm going to divide those by 2. Now this is going to give me my new point. So I'm going to have -3 plus 4 is 1 over 2. And then I'm going to have 2 plus -2, which is 0 over 2. Now remember, 0 can be divided into, so we can take 0 divided by 2, and that's just going to return 0. What we could never have, put it in red, if we ended up with this, that's undefined. Any number cannot be divided by 0. So 0 divided by a number is fine. It's always going to give us 0. Let's change out red. So our new point is 1/2, 0. Now let's mark it on the graph. So my y value is 0. My x is 1/2. So I'm going to go 1/2. So here's 1. 1/2 is right here. And I'm going to go up 0. That is our midpoint of this line. All right, let's look at the partition of a segment. It's very similar. So now it wants to know what are the coordinates 3/5 of the way from A to B. So we're going to start by finding the change in the x and y coordinates. How can we do this? Change is much simpler than the midpoint formula. Change is my x went from 3 to 13. So how much did it move? So I take the absolute value because that is a length. It moved a length, and I have 13 minus 3. I can also do 3 minus 13 and get -10. Find the absolute value of that, and it's 10. Again, I always use the number on the right, or for R squared space, or R2, which is our coordinate plane, I always take the number on top when we're looking at y's, minus the number at bottom when we're looking at y's, and then for the x, I take the number on the right minus the number on the left. That way I'll always have the best chance of having a positive number, and if I forget to take the absolute value, it's really not going to hurt me. So now I know the change in my x is 10, and my change in y is 15 because 11 minus negative 4 is the same as 11 plus 4, which gives me 15. So my change in y is 15. Now this is the part that is one of two. It's either very easy because we can just get it right away, or we want to see it 1 or 2 times. So luckily it's on a video. Rewind it, ask questions in class, message me on Edsby if you have any questions about this. But it wants to know what are the coordinates of the point 3/5 of the way from A to B. So I know the changes in x is 10 and the change in y is 15. So what I'm going to do, let's I guess bring it over here. So I'm going to take my x change, which was 10. I'm going to multiply it by 3/5. I'm going to take my y, which was 15, and multiply it by 3/5. So there's 2 ways we can do this. I'll show you both because I'll do both in class. Kind of want this to be a natural thing. This is the same as 10 over 1 times 3 over 5. When we multiply, we go straight across. So 10 times 3 is 30, and 1 times 5 is 5. And then that 30 divided by 5 is 6. Here we have 15 times 3 because this is 15 over 1, so straight across gives me 45 over 5, which is 9. So our new x coordinate, our new coordinates altogether are 6, 9. So remember, this was our x, this was our y. So the point 3/5 of the way from A to B is 6, 9. Now let's look at it one more way. This is the way I just showed you, is the way I'll probably do it, more in the beginning of the year. The way I'll probably start transitioning you to thinking, because it's much quicker. It simplifies right away. This is still 10 over 1, but I can cross. Look at these. How many times does 5 go into 10? All right, so I can simplify and make this a 2. And then I can say 3 and 1, that doesn't really change. This is just 3, so I'm going to end up with 2 times 3, which is 6. Same here. 5 goes into 15 3 times. This doesn't change, so 3 times 3 is 9. Still gives me the same coordinate. These are both different ways to do it. I like this way, it's faster, even though I kind of paused there for a minute. Alright, so I believe the next slide is participation. Again, participation, whenever you see a P. See, here we had an N. This is your notes. You take your notes how you want. Make sure they're in your binder. But when I do the notebook check, I'm not going to look too hard at your notes. I'm mainly concerned with your vocabulary, your participation, and that you saved your quizzes and tests. All right, so here's your participation. And I want you to find the coordinates of the point described 7/10 of the way. Looks like we have the same problem, so you already have a head start. You know the changes are 10 and 15. And you're just going to move from there to find basically what amounts to 7 over 10 is 70%. So what is 70%? If I were to travel from A to B, but I wanted to stop 70% of the way to plan a meal or use the restroom because I have kids in the car, where would I stop on this map? All right, now we're going to look at the distance formula. All right, so let's talk about the distance formula. So we are going from R space, which is the number line, because it's just one dimension, to R2 or R squared space, which is a horizontal line and a vertical line. You know that as the coordinate plane. The X is horizontal, the X plane is horizontal, and the Y plane is vertical. So this is the distance formula. And again, it involves 2 points because we're finding the distance between 2 points. We'll usually call those points P and Q in this class just to keep everything simple. Now, if you look here, this little d just means the distance between P and Q. That's how we read that. The distance between P and Q is equal to the square root of the difference of the second x coordinate and the first x coordinate. Difference of meaning subtract. So the difference of this coordinate and this coordinate means second coordinate minus the first coordinate, and then we square that value. Then we add the difference between the second coordinate and the first y coordinate and square that value. Add those together, then take the square root of that number. I've broken down, and you can put this in your notes and you can use this on your quiz. That's fine. These are the exact steps. This is PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. That's broken down in that order, so you can get practice with it in your notes. You can get practice with it on the quiz. This will not be available during the test, so make sure you're comfortable with it before we take the test on this unit. Alright, so let's look at an actual problem. So now we're going to actually do the distance formula. Remember, it's our second x term minus our first x term, square that value, then add the difference between the second y term and the first y term, and then square that value. Then take the square root of all of that. So let's do this. Let's see, point A will give us our x1 and our y1. And let's do, what is our value here? Our x1 is 3, our y1 is 4. Now our B is our x2 and our y2, and those are -3, -4. That's interesting. Let's see what this plays out to be. So my x2 is -3. My x1 is 3. So I have x1, or x2, sorry, which is -3, minus my x1, which is 3, squared, plus my y2, which is -4, minus my y1. My y1 is 4. We're going to have that squared, and then we're going to take the square root of that. So -3 minus 3 is -6. Always do inside the parentheses first, plus -4 minus 4 is -8 squared. That is a bad squared. And I now have, my next thing is to do my exponents, because there's nothing left inside the parentheses. -6 squared is 36. Now again, we're dealing with lengths. Lengths can never be negative. We don't use the absolute value on this because any number you square in the real number line, which is the number line we're working with, will always be positive. So -6 squared is 36, just like 6 squared is 36. -8 squared is 64. 36 plus 64, that's under the radical, so we have to do that first, is 100, and the square root of 100 is 10. So the distance of AB is equal to 10 units. Alright, and it's the same thing if we did BA. Distance is the same either way, so that is our distance formula. Now here's a recap of 1.3 for you. I paused the video, take this down, but you do have the midpoint formula, which is again the average of the x coordinates and the average of the y coordinates to create a new point, and that's exactly in the middle. If you want to find the segment length or a percentage of that, you would multiply it by the segment modifier and get wherever that segment lies. So if it was 60% of the way, you would do 0.6 or 6/10 that you would multiply by. Then you have your distance formula, which we just covered. And here's an example on one segment, the segment PQ, where we find the distance formula and we find the midpoint. So here's our midpoint at -1, 11/2. We went back 1, and 11/2 is 5.5. So there's 5, and that's 5.5. Our distance is a total length of 5. The homework is on Edsby. I know it's absent Tuesday through Friday last week, so we're going to extend the due date on it. I'll talk to you in class about that Monday and Tuesday for, Monday for blocks 1 through 4 and Tuesday for blocks 5 through 8. And the quiz is also going to be moved, obviously, and we'll talk about that in class as well. That is 1.1 and 1.3.